Hi, everybody. Today we're going to look at solving rational expressions or equations, rather. This is the final section that we will have for our next exam. So, in the next couple of days, expect a review guide along with me going over that review guide. Okay, so here we go. Okay, so this is a document that was sent to you. This is part of your notes. Okay, so solving rational equations. A rational equation is an equation containing at least one rational expression. Remember, that's a fraction. Rational expressions typically contain a variable in the denominator. For this reason, we will take care to ensure that the denominator is not zero by making note of the restrictions and checking our solutions. Okay, remember the restrictions: set the denominator equal to 0, solve for x, or whatever the variable is, and that tells us the restrictions. Any solution that's one of those restrictions has to be thrown out. It's called extraneous. So let's look at example 1. In example 1, we have 5 over x minus 1/3 equals 1 over x. Okay, make note, x cannot equal 0. Okay, now just like when we started looking at equations with fractions, we multiplied everything by the common denominator. We're going to do that here. Since our denominators are 3 and x, our common denominator is going to be 3x. So I multiply everything by 3x on both sides. I'll distribute the 3x here. That gives us 3x times 5 over x minus 3x times 1/3. And then here we get 3x times 1 over x. Now, I have an x here and an x here. I'm going to cancel. That gives us 3 times 5, or 15. We have a 3 here and a 3 here. We're going to cancel. That gives us x times 1, or x. And here we have the x and the x again, which gives us 3 times 1, or 3. So that gives us the equation 15 minus x equals 3. Solving for x by isolating, we get x equal 12. X equal 12 is not the restriction of 0, and so it's a good solution. And we can check that if we need to, okay, by plugging 12 in for x and evaluating. Let's take a look at another example. This is example 2. We're going to solve 2 minus 1 over x times the quantity x plus 1 equals 3 over x plus 1. So here our denominators can't be 1 and minus 1. And also, the single x can't mix the denominator, so we can't be 0. Okay? So we begin by multiplying both sides by the common denominator. So what's the common denominator? Well, we have a 1 underneath the 2, so that really doesn't contribute much. We have an x times the quantity x plus 1 and an x plus 1. So the x plus 1 has to be in the common denominator, and the x does. So that means x times the quantity x plus 1 is our common denominator. Okay? So looking at this, I multiply both sides by x times the quantity x plus 1. I distribute the x times the quantity x plus 1 here. It doesn't cancel with anything with the 2, so it stays around with the 2. So that means I'm going to multiply the 2, the x, and the x plus 1 eventually together down here. With the 1 over x times the quantity x plus 1, I multiply that. X matches up, and x plus 1 matches up. So the entire denominator here canceled along with what I multiplied by, so that gives us minus 1. And then over here, the x plus 1's match up, leaving us with x times 3, or 3x. Solving the equation, we have a quadratic equation when we distribute the 2x. We'll move this 3x over by subtracting, setting it equal to 0. We can use a quadratic formula, or we can factor, whichever one we want to do. I chose to factor here. I have a 2x squared minus an x minus 1. Using the AC method, I found that the factors are 2x plus 1 and x minus 1. Again, you can use a quadratic formula. I set each factor equal to 0 and solve. This gives us x equals minus a half for one and x equals 1 for the other. Now, if we recall, were either of those a restriction? And the answer is no. The restriction was minus 1 and 0. Okay. So both are solutions. Let's take a look at another one. Here we have x over x plus 2 over x squared minus 5x plus 6 equals 5 over x plus 3. Now to find a common denominator, we're going to have to factor. And in fact, to find restrictions, we're going to have to factor. And in particular, this x squared plus 5x plus 6. So we need two numbers that multiply to be 6 and add up to 5. 3 times 2 is 6, and 3 plus 2 is 5. So that's our factorization. That also ends up being the lowest common denominator here. That also ends up being the lowest common denominator, x plus 2 times the quantity x plus 3. Our restrictions, x cannot equal minus 2, and x cannot equal 3, or minus 3 rather. Don't know how those got repeated. So we're going to multiply both sides by the quantity x plus 2 times the quantity x plus 3. So again, same idea. When I distribute this here, the x plus 2's will cancel, giving us x times x plus 3 as a quantity. When I distribute it here, everything reduces out, leaving us with just 2. And then when I multiply it over here, the x plus 3 cancels, giving us 5 times the quantity x plus 2. Simplifying by distributing the x, we get 3x squared plus 3x plus 2. Distributing the 5 gives us 5x plus 10. Our fourth step, set it equal to 0 since it's a quadratic equation. I'll subtract 5x and minus 10 from both sides. That gives us x squared minus 2x minus 8 equals 0. Again, I could use a quadratic formula or I could try to factor. This factors, I think, pretty quickly because we need two numbers that multiply to be minus 8 and add up to minus 2. So that means 2 times minus 4 is minus 8, and 2 plus minus 4 will be the minus 2. So we set each factor equal to 0. We get x minus 2, x equals minus 2, and x equals 4. Now recall, x equal minus 2, and we go back up here. X equal minus 2 was one of our restrictions. X cannot equal minus 2. So that's what we call this right here. This x minus 2 is what we call an extraneous solution. So we toss it out. And in fact, we can see that when we plug it in. It makes the denominator 0. That's undefined. So can't use it. Got to throw it away. And so our only solution then that doesn't make a denominator 0 is 4 and makes the equation true. So our solution is x equal 4. Hopefully this helps you out. And hopefully we can get through this. We have an exam coming on the 23rd. Yeah. That exam you can take a couple of times to get a better grade. As I said before, this is a difficult subject for people. So don't sweat it. We'll get it. First time through, sometimes we don't get it. Second time through, we do a little better. Third time through, we might do great. Okay, that's the idea here. Just keep improving. Okay, take care. We'll see you next time. I'll send out a review pretty quickly the next day, and we'll cover it by the 23rd. Take care.